Have you ever wondered if your choices are truly your own? I mean, really, fundamentally your own? The structure of classical mechanics, the physics that governs everything from a thrown ball to the orbit of the planets, suggests something pretty startling. It implies that if you knew the exact position and velocity of every single particle in the universe at one moment, the laws of physics would precisely determine everything that happens next. Not just for the next second or the next year, but infinitely far into the future. And not just the future, you could also perfectly reconstruct the entire past. Now, this might make you a little uncomfortable. You might be thinking, hold on a second. I'm a person. I have free will. I decide what to have for breakfast, who to talk to, what to think. My life isn't just some pre-written script dictated by the laws of physics. Well, you're not alone in feeling that way. This very idea has been a battleground for scientists and philosophers for centuries, and guess what? They still don't all agree on what it all means. I'm Sean Carroll, a physicist and philosopher at Johns Hopkins University, host of the Mindscape podcast, and author of several books, including the Biggest Ideas in the Universe series. Today, we're going to dive into this mind-bending concept, the determinism of classical mechanics. Is our reality just an intricate cosmic clockwork machine ticking along a predetermined path? Physics can often seem intimidating and difficult. Paradoxically, I think that's because, at its core, it's actually incredibly simple. When we first study physics, we re-hit with a barrage of abstract concepts and equations that we just do and encounter in our daily lives. But the reason those ideas are so powerful, the reason they work so well, is because physicists have mastered the art of stripping away the world as overwhelming complexity to reveal its simplest, most fundamental forms. Think back to your high school physics class. Remember all those examples? Frictionless surfaces, perfectly elastic collisions, pendulums that swing forever in a vacuum. These are all idealized models. No real surface is perfectly frictionless, and no real pendulum swings forever. Physicists intentionally remove all these messy complications to find the universal patterns, the underlying rules of the game. Once they have those, they can start adding the complexity back in, layer by layer. This reductionist strategy, this process of simplifying to understand, wouldn't get you very far in fields like psychology, biology, or political science. The systems are just too complex and interconnected. But in physics, it has been astonishingly, breathtakingly successful. There's a classic joke that physicists tell. A dairy farmer is struggling with low milk production and asks a physicist for help. After weeks of intense calculation, the physicist returns and proudly announces, "I have the solution, but it only works for spherical cows in a vacuum." It's funny because it's true. Of course, real cows aren't spherical. But the joke perfectly captures the physicist's instinct to simplify, to model a complex lumpy system as an ideal perfect shape that can be easily described with mathematics. This approach might not work for dairy farming, but it works beautifully for things that are pretty close to spherical, like planets, stars, or even the entire universe. The first great revolution in physics, the one that set all of this in motion, was classical mechanics, established by the monumental work of Isaac Newton and his predecessors. Before Newton, the prevailing wisdom came from Aristotle, who believed that objects had natural tendencies and preferred places to be. A rock falls because its natural place is on the ground. Smoke rises because its natural place is in the sky. Newton completely shattered that worldview. He proposed something radical. If an object isn't being acted upon by a force, it doesn't try to go anywhere. It just keeps moving in a straight line at a constant speed forever. And if a force asterisk is asterisk acting on it, there's a precise mathematical way to calculate exactly how its motion will change. This was a universe governed not by tendencies, but by unbreakable laws. Physicists love simple, clean systems, and a billiard table is a fantastic analogy for this new Newtonian universe. But let's imagine the most perfect billiard table ever. The surface is perfectly smooth and frictionless. The balls are perfect spheres that never lose energy when they collide. There's no air resistance, no sound, and no pockets for the balls to fall into. In this idealized billiard world, if you were to set the balls in motion, they would move and bounce off each other endlessly, forever, without ever slowing down. Now, here is the crucial part. If you knew the exact position and velocity of every single ball on that table at any given moment, you could use Newton's laws to predict with absolute total accuracy where every ball would be at any future moment, from now until the end of time. But it doesn't stop there. You could also run the movie backward. By looking at their current positions and velocities, you could reverse engineer their entire history, calculating exactly where they were a minute ago, an hour ago, or at the very beginning of the game. We do and experience this kind of perfect determinism in our everyday lives because the real world is messy. It has friction, noise, and energy dissipation. A real billiard ball eventually slows down and stops. But in Newton's idealized framework, time is symmetrical. The laws work just as well going forward as they do going backward. The past and the future are equally determined by the present state of the system. Newton introduced this revolutionary framework in the 1600s, and it sent shockwaves through the scientific and philosophical communities. It was thrilling. The universe wasn't a mystery, it was a puzzle that could be solved. Over a century later, a French mathematician and astronomer named Pierre-Simon Laplace took this idea to its ultimate logical conclusion. He reasoned that the universe itself is just a grand collection of particles, just like the billiard balls on the table. So he thought if you could know the position and velocity of every single particle in the entire cosmos at one specific instant, and, crucially, if you had a mind with infinite computational power, the laws of physics would allow you to know everything. The entire future history of the universe and its entire past history will be laid bare before you. Laplace imagined what he called a vast intelligence, which later became known as Laplace's demon. For this hypothetical super-intelligent being, he said, nothing would be uncertain. The future, just like the past, would be present to his eyes. In this clockwork universe, everything that is happening right now is the inevitable consequence of what came before and the absolute cause of everything that will ever happen. Your decision to watch this video, the words I'm saying, the thoughts forming in your head, all of it, according to this view, was set in motion at the Big Bang. So, this brings us back to that unsettling feeling. If the universe is a clockwork machine, what does that mean for us? For our sense of self, our creativity, our morality, our freedom to choose? Are we just cogs in a cosmic machine, playing out a predetermined role? Or is there something more to the story? This is where the clockwork universe collides head-on with the human mind and where things get really, really interesting. Thank you so much for joining me on this journey into the biggest ideas in the universe. If you found this fascinating, please give this video a like, and don't forget to subscribe and hit the bell so you don't miss our next exploration. What do you think about determinism? Let me know in the comments below. Have you ever felt like you're the captain of your own ship, steering through the seas of life, making one choice after another? You decide what to have for breakfast, which movie to watch, what career path to follow. This feeling of control, this ability to choose, is what we call free will. It feels incredibly real, doesn't it? But what if I told you that this fundamental sense of freedom might just be an illusion, a beautiful, intricate story our minds tell us? Let's journey back a few centuries to the age of Isaac Newton. His laws of motion and gravity were revolutionary. They showed that the universe wasn't some chaotic, unpredictable place. Instead, it behaved like a magnificent, intricate machine, a giant clockwork. If you knew the position and momentum of every single particle at one moment, you could, in principle, predict the entire future of the cosmos and reconstruct its entire past. This idea is called determinism. The universe just ticks along, following unchangeable physical laws. This clockwork universe concept was famously captured in a thought experiment by the French scholar Pierre-Simon Laplace. He imagined a vast intellect, a being he called a demon. This demon would know the precise location and momentum of every atom in the universe. For such an intellect, Laplace argued, nothing would be uncertain. The future, just like the past, would be present before its eyes. Think about that for a second. If everything is predetermined, from the collision of distant galaxies to the path of a falling leaf, what does that mean for us? You, me, our thoughts, our actions, we are all just complex collections of atoms. If the universe is a clockwork, then aren't we just cogs in the machine? Every decision you've ever made, every word you've ever spoken, could have been predicted since the Big Bang. The feeling that you chose to watch this video. According to strict determinism, it was inevitable. This is a deeply unsettling idea. It seems to rob us of our agency, our responsibility, our very identity as individuals. If our actions are predetermined, how can we be praised for our good deeds or blamed for our mistakes? The entire foundation of our moral and legal system seems to crumble. Are we just puppets on cosmic strings, dancing to a tune written at the dawn of time? This is the great clash between determinism and free will, a debate that has raged for centuries among philosophers and scientists. It feels like we have to pick a side. Either the universe is a predictable machine, or we are genuinely free agents. It seems impossible for both to be true. But what if there's a third way? A way to reconcile these two seemingly contradictory ideas? This is where a fascinating philosophical position called compatibilism comes into play. Compatibilism suggests that free will and determinism can, in fact, coexist. It sounds like a paradox, right? How can you be free if your future is already written? The key lies in understanding what free will really means from a human perspective. Let's go back to Laplace's demon. The demon's power comes from having complete information about the universe. It knows everything. But what about us? We are not all-knowing demons. We are finite, limited beings. Our brains, as powerful as they are, can't possibly know the exact state of every particle in the universe, or even every particle in our own bodies. Imagine trying to store the information of your own brain inside your brain. It's a logical impossibility. The more memory you add to your brain to store this data, the more brain matter you have, which means there are now more particles to track. You can never contain a perfect, complete model of yourself within yourself. The map can never be the territory. So, Laplace's demon is just that, a thought experiment. It cannot exist in the real world. No physical entity within the universe can have the computational power to perfectly simulate the universe it's as a part of. We are fundamentally limited in our knowledge. And this limitation is precisely where our experience of freedom comes from. Because we lack this God's eye view, because we can't know the complete state of the universe, we have to navigate the world using simplified models. We cut and track every single neuron firing in a friend's brain to predict what they'll say next. Instead, we use a much more practical model. We think about their personality, their past experiences, their likes and dislikes. We treat them as an agent who makes choices. You don't think. The atoms in Sarah's brain are configured in such a way that she will inevitably choose the chocolate ice cream. You think, Sarah loves chocolate, so she probably choose that. You're modeling her as a decision maker. And we do the exact same thing with ourselves. You don't deliberate over a choice by calculating the quantum state of your neurons. You weigh your desires, your values, your goals. You think about the consequences. You feel the pull of different options. This internal process of deliberation is what we experience as making a choice. According to compatibilism, this is what free will is. It's not about breaking the laws of physics. It's about acting according to your own character, desires, and reasoning, without being coerced by external forces. If someone puts a gun to your head and forces you to do something, you're not acting freely. But if you sit down, consider your options, and make a decision based on your own internal state, you are acting freely. The fact that this internal state, your thoughts, your desires, your personality, is itself a product of a long chain of cause and effect stretching back to the beginning of time doesn't negate the freedom of the act. Your past, your genes, your upbringing, your experiences shape the person you are today. But it is the person you are today, who is making the choice. So, even if the universe is deterministic at the most fundamental, microscopic level, the most accurate and useful way for us as limited beings to understand ourselves and others is through the lens of agency and choice. Thinking about human behavior in terms of free will is the correct level of description for the world we actually experience. Imagine trying to predict the weather by tracking every single air molecule. It's theoretically possible in a deterministic universe, but practically impossible. Instead, meteorologists use models based on pressure systems, temperature gradients, and humidity. These are higher-level descriptions that work. Similarly, psychology, sociology, and our everyday understanding of people are the higher-level descriptions that work for human behavior. We don't need to go down to the level of atoms. So, are you free? Well, you're not a supernatural being who can defy causality. You are part of the physical universe. But within that framework, you are a complex, self-reflecting system that deliberates and acts based on its own internal reasons. Your choices are meaningful because they flow from who you are. The feeling of freedom isn't an illusion to be dismissed. It's an emergent property of our complex brains and our limited perspective. You are not Laplace's demon. You don't have a God's eye view of reality. And that is precisely why your life feels like a journey of your own making, a series of meaningful choices that define who you are. The future may be set, but it's a story that you still have to live, and your choices are the ink with which your chapter is written. Thank you so much for exploring this deep question with me today. If you enjoyed this journey into the mind, make sure to hit that like button and subscribe for more videos that question the nature of our reality. I'd love to hear your thoughts in the comments below. Do you believe in free will? See you in the next one.